Okay, so here's a different example, or suppose our first example, our true example of looking at uh, composite functions. So we have f of x is equal to 2x, g of x is x plus 6, and they want to know what is f of g of x. And again, just to reiterate, a different way to write this is with g of x inside the parentheses of f. Okay, so we're putting this statement in here, okay, inside these parentheses. So when you write it like this, again, this is, this tells the story of what we're supposed to do. We're supposed to make g of x the input into f, right? What does f do, right? The function f, as it's shown up here, takes 2 and multiplies it by whatever the input is. So if I make the input g of x, and I replace this g of x with what it actually is, right? What that function actually is, that means I'm supposed to take x plus 6 and put it in for the x. The parentheses are key here, okay? I hesitate to even write this, but if you write this, you're like, yeah, I put x plus 6 here, right? There was already an x there, so all I had to do was put plus 6. You're missing the mark if this is what you're thinking, okay? X plus 6 is the input. So I have to put x plus 6 in for the x. That's why I'm replacing that with this whole binomial. And then when we simplify that, we get 2x plus 12. So this is our function f of g of x, right? This is our new composite function. All right, let's look at the g of f of x. What if we switch it around? Okay, if we switch it around, we can do this. All we do now is we take, again, if you look at what this is saying, g of f of x is g of f of x. So now we're taking f of x, which is this, and we're plugging it in here, right? So this becomes g of 2x, which means I'm taking 2x and I'm plugging it in wherever the x used to be. Right? Because what does g do? The function g takes its input and it adds 6 to it. So if the input is 2x, then I take 2x and I add 6. I get 2x plus 6. Okay, so here is the function g of f of x. Now, how do we use compositions to do evaluations? There's two ways to go about this. Okay, let's look at it this way. There's two ways to think of this. Okay, one way is I already know what the function f of g of x looks like. It looks like this. So since I've already done the composition and I have this, whatever number goes here goes here. So I've made this composite function already and simplified it. So if I want to know what f of g of 3 is, okay, fog 3, if you will, all I have to do is put the 3 in for the x, right, as the input into this place right here. So we end up with 6 plus 12, which is 18. Now, the alternative option here, so this is fine, right? We're plugging that number into the composite function. The other way to look at this, okay, and this is talked about in the previous slide, okay, plug this into G first. Whatever you get as a result, plug that into F, okay? So a different way of looking at this is to say, okay, let's see what's G of 3, right? G of 3, if this is the function G of X, and I plug a 3 here, that means I'm plugging a 3 here. So I know that, and I can go off to the side and say, well, G of 3 is equal to 9 because 3 plus 6 is 9. That means 9 is now the input into F. And now I'm just using the old function F for this, okay? So I would take 2 times 9, and 2 times 9 is 18. So I get the same answer. So again, there are two ways to do problems like this. Dial in for this part. Hope you're paying attention. Okay. Take the input that they're giving you and plug it into the composite function. Figure out what that composite function f of g of x looks like first, and plug that number into it. The other option is to only put that number in to the first function, get an output for it, and then plug that number into the outside function. Okay, let's do this last one. G of f of 3. Okay, so now they want to know what's g of f of, of 3. We know that we just did g of f of x up above. G of f of x, we got to be 2x plus 6. So we could say this is, if this is 2x plus 6, then g of f of 3 is 2 times 3 plus 6, which is 12. All right. Or, let's say, or, alternative method. Think of it like this. This is the same statement, g of f of 3. So figure out what's f of 3. That's what I get when I plug a 3 in here. So if I plug a 3 in here, I get 6, right? So the output for f of 3 is 6. Now take 6 and plug it into g. And if I plug it into g, the function g just adds 6. So we get the same answer. Okay, so you should get the same answer regardless of how you do this.